In this video, we're going to look at bone physiology and histology. This is a cross-section through a long bone. We're looking at compact bone here. If we zoom in, you can see it's got some structures here, so we're going to examine those in the next few slides. So bone tissue or osseous tissue is a type of connective tissue. If you remember, connective tissue has an extracellular matrix. The extracellular matrix consists of the protein fibers as well as ground substance. So let's look at the protein fibers first. Just like the other connective tissues we saw, bone is high in collagen fibers. About 1/3 of the mass of bone are from collagen. Remember that collagen is tough and flexible, can tolerate some degree of stretching and twisting and bending. However, under compression, the collagen simply bends out of the way. And the collagen fibers provide a framework for mineral crystallization. Mineral crystallization leads us to the ground substance. It's what the ground substance is. It's minerals like calcium phosphate and hydroxyapatite and calcium carbonate and magnesium ions and fluoride ions. So that inorganic material, those mineral crystals, account for 2/3 of bone mass. And interestingly, this inorganic bone, these inorganic mineral crystals can withstand compression, but are inflexible and will shatter when bent or twisted or under impact. So the collagen fibers have some favorable attributes, and so does the mineral deposits. But the two of them together, what they do is they end up combining to produce a composite material that has properties that are sort of like the idealized version of the best of both. The properties come out in bone. Let's look at the types of bone cells. We have osteocytes. Those are mature bone cells. They monitor and maintain the extracellular matrix. Remember, the extracellular matrix is what we just talked about. That's the protein fibers and the mineral content. The osteocytes direct the release of calcium from bone into blood, and also the deposition of calcium salts into the extracellular matrix. It's a lot of words there, but basically it directs the coming and going of calcium. Here's a great picture of some osteocytes. Notice here's the cell body, and it has all these cytoplasmic extensions, which we'll call canaliculi in the next slide. Here's a cartoon drawing of it. Here's the osteocytes. Here's these extensions called canaliculi. And then those canaliculi perforate through the bone matrix or through the crystals and the collagen fibers. We have osteoblasts. Blasts are immature bone cells. These are found in the periosteum and the endosteum, and they secrete the organic components of the extracellular matrix, like the protein fibers. If osteoblasts become surrounded by matrix, then the osteoblast will differentiate into an osteocyte. And then the process by which we get the mineralization of that material, not really sure about that. They didn't even have that process developed or explained when I was in college. I think we know more about it now, but we're not going to look at it in too much depth. So here's a cartoon drawing of some osteoblasts. The takeaway here, though, is that the osteoblasts are the bone makers. They lay down some of the extracellular matrix. Then we have osteoclasts. Those sort of do the opposite of the osteoblasts. They're giant multinucleated cells, and they produce acid to dissolve the matrix. And then when they dissolve the matrix, it releases calcium ions and phosphate ions back into the blood. So you can think about osteoclasts being the bone breakers. So they're doing, these two cells are doing sort of opposing things, but the balance between the two is what maintains homeostasis. I forgot to show you the picture here. Here's an osteoclast with its many nuclei. So like I mentioned, the balance between the blast and the clast activity maintains homeostasis for your body. And even though year to year the amount of bone material you have stays roughly the same, every year or so, about 5% of the bone calcium is turned over. So after a period of many years, you'd have all new bone. So
Look at the structure of bone. We've learned that there's compact bone, which you can see here, and then spongy bone, which is the bone here. The compact bone is organized into osteons. So this, for example, would be one osteon. In these lacuna, or if there's multiple, you say lacunae. In these lacunae is where the osteocyte sits. Remember, the osteocyte is like the bone cell. And the osteon is laid down in sort of concentric circles, or called concentric lamella. If you notice, the spongy bone over here does not have osteon, so that's one way you can distinguish them apart. Another way is simply by looking at it. The compact bone looks compact, and the spongy bone looks very spongy. It has these sort of plates and struts. And then the osteocyte sitting in the lacuna has these projections that come off of it. These projections, and you can see them all, right here, those are called canaliculi, and the osteocytes are able to communicate through the canaliculi. So here's a little cartoon of an osteon. It looks like the mineral deposits have been dissolved away, and you just see the living portions. You see the osteocytes with the canaliculi. And then this is under microscope here. So we see one osteon here, and then another osteon over there. And these darker stains, those are the osteocytes. And then you can see the lacunae, you can see the canaliculi here. And this is the central canal where you'd have the artery, the vein, and the nerve. Here's some more. Here's an osteon here. There's another osteon there. Here's one big osteon that we've zoomed in on. Here's the central canal. Remember, you'd find the artery, the vein, and the nerve there. And this would be an osteocyte. That's an osteocyte. And connecting the osteocytes are those little arms, remember, called canaliculi. So on the left, we can see, at least a dozen osteons, and on the right, we're pretty much zoomed in on just one, and you can see the osteocyte really well and the canaliculi really well. And there's the central canal.